Hello everyone, my name is Bella Newby. I am a senior at Clear Springs High School, and today I will be going over significance testing, specifically in problems involving proportions. So, what is significance testing, you may ask? A significance test is a formal procedure used to compare observed data with a claim or hypothesis to the truth of which is being assessed. And what is a claim in statistics? Well, a claim is a statement about a parameter, which is a number describing a whole population. So in this case, we're going to be using population proportion, but you can also use population mean. So let's start on our practice problem. So the problem says, according to an article in the San Gabriel Valley Tribune, are people kissing the right way? That is, according to the study, the majority of couples tilt their head to the right when kissing. In the study, a researcher observed a random sample of 124 couples kissing in various public places and found that 83 out of the 124, or specifically 66.9% of the couples, tilted to the right. Assume that the population percentage is 50%. So our first question is, state the appropriate hypotheses. To do that, you're going to want to start with your null hypothesis, which is what you expect it to be. So that's going to be P, or proportion of the population, is equal to 50% who tilt their head to the right. And then our alternative hypothesis is going to be what we want it to be, which is going to be proportion is greater than 50%. Using that info, we can go to the next question, which is, what is the test statistic? So for proportions, the test statistic is going to be the z-score. And to find the z-score, we're going to use the equation z equals sample proportion minus hypothesized value of population proportion divided by standard deviation of the sampling distribution. So to do this, we're going to find it the longhand way first. Even though most of you probably don't want to do this, it's important to do and to know how to do it both ways, not just on your calculator. So, first, as you saw, the standard deviation was included in that formula, but we don't have that yet. So we're going to have to solve for that as well. And the equation in this case for standard deviation is going to be the square root of the hypothesized value of the population proportion, or the null hypothesis, times Q, which is 1 minus that same hypothesized value, over your sample size. So plugging that information in, we're going to have 50%, which was our null hypothesis, times 1 minus 50%, which is going to be our Q value, over 124, which is our sample size. And we're going to get somewhere 0.045 is what I got, but depending on how you round, you can get different answers. So with this information, we can go on to our z-score equation, and it's honestly not that much different. All we have to do is plug in our 66.9%, which is our proportion in our sample, minus the proportion of the population that we're hypothesizing, over that same standard deviation. And you should get somewhere near 3.7. Now, to take a break, I included a meme, and it says, sees a slightly complicated math problem, OMG. Now, finding your z-score and p-value by calculator. So we're going to have our same two questions. I'm just adding on the p-value because it comes with the calculator function. So to find your z-score or test statistic and p-value through your calculator, we're going to follow these steps. And for me, I will be using a TI-84 plus calculator, but if you have any graphing calculator, it will work. So for step 1, we're going to press stat on our calculator, which is going to be 2 away from alpha to your right. And we're going to, once we press that, you're going to go over 2 times to test, and your calculator screen should look like the picture on the screen at this point. And once you get to that screen, you're going to go down to 5, which is the one prop z test. Now that your screen looks something like the bottom image, except it should be blank, we're going to plug our information from the problem in. So for P, which is the very first value, we're going to use our null hypothesis proportion of the hypothesized sample proportion, and that's going to be 50%, but when you're plugging in, you're going to want to make sure to put 0.5, not the 50. And then X is going to be our number of successes, which in this case is the number of couples who did tilt their head to the right when kissing, and that was 83. And then for our sample size, it was 124 in this case, which is N. And for the proportion, we're going to want that it's greater than P, or P is greater than 0, which is our alternative hypothesis in this situation. And once you press calculate, you should get a z-score of around 3.7, which should be very similar to our longhand. And the difference with this one is it's going to give you your p-value as well, which for me, I got 8.11 times 10 to the negative 5th value, which, as you can tell, is a very small number. So going on to the next questions, what is the p-value, and interpret what this means. So as we said, the p-value is 8.11 times 10 to the negative 5, which is a very, very low number, meaning that there is great statistical significance of that observed value. So what this means for whether we accept or reject our null, that p is equal to the 50%. In this case, since the p-value is so low, we will reject the null hypothesis. We have convincing evidence that the couples who kiss with their head tilted to the right is greater than 50%, which means we're basically accepting our alternative hypothesis, if that makes sense, and like throwing out a null. So, what can we conclude from this? We can conclude that greater than 50% of all couples who kiss in public will do so with their head tilted to the right, which once again is our alternative hypothesis. So, with that, we are done with the question, and that is significance testing for proportions. Have a great rest of your day.